Thank you. So I'm going to speak to you today about OWL and how we're using geofencing technology really to improve track worker safety. And really, as we've talked about a bit earlier, I heard about that loss of situational awareness, which is a key factor in, unfortunately, many of the incidents and close calls that we see out on the network. And I've got to start with a couple of thank yous. As Nick said, we've been working together for a couple of years on this project, on the geofencing project. And what's really been apparent is the drive of the team in the safety task force, to get the benefit from geofencing, and also from the regions who've participated in the trial as well, so Western region and Southern region as well. And that feedback has been really important in helping us getting the most out of the project and look at what further we can do as well with OWL. So I'm going to talk to you today really about the main outcome, preventing that loss of situational awareness. We'll talk a little bit about the technology as well behind OWL, how it all works, and also about some other use cases as well. So what we're seeing in other sectors and hopefully share some knowledge and learning there as well. So just to start, as I say, the primary outcome that we were looking for is really preventing this loss of situational awareness. And it happens for so many reasons out on track. So, people being really engrossed in their work. Other times, perhaps there's distraction, there's something on their mind, something from outside work as well. It might be they're working in a new location that day, they're not familiar with their surroundings, so how do we improve that? And sometimes the opposite is true. We've got over-familiarity as well. They're working somewhere so often, we almost become blind to the risks and the hazards that are presented to us. So all these situations, that's something that we want to overcome. And the purpose of OWL and the geofencing technology that we use is really if someone does inadvertently step into harm's way outside their work area, outside the area where there's an isolation or a lock-off, then we give them that tap on the shoulder just to bring them back and make sure that they don't step into harm's way. That's the fundamental principle of what we're trying to do. And as a byproduct of that as well, the other thing we can do is improve people's visibility as well of the work site. So where our people, our plant, our resources at any point in time. So to give the supervisors an overview of where everybody is at that point in time. And that's really important from a safety point of view as well. So just stepping back a moment, what is geofencing? And I'm sure a lot of you will know the principles of geofencing. But what we effectively do, we create a virtual zone, a virtual boundary on a GIS type interface, a Google Maps type interface, and then we monitor the location of people and plant, and we can trigger alerts effectively as people and plant interact with these zones. So that's a very basic fundamentals of geofencing and how we use it with OWL. And a little bit about more the technology that we use and the various components. The portal, so that's really the control center of OWL. That's where we create our zones. We set our alerts. What alerts do we want to trigger? Put our possession limits in there. So all hazard zones, we can create zones around whatever we want really. And we can attach documentation and further information to those zones as well to help that cascade out to people in the field as well. So a lot of the input happens there. It's very simple to create zones and to upload them as well. And we often upload, typical GIS files is how we take that up onto the system. The other thing with the portal as well is the outputs as well. So we can collect data on, where alerts have been triggered. So there might be a specific location on the network where there's quite a lot of alerts been triggered. So that's an indicator for us that, perhaps we need to go and have a look at that. So it gives us some insight into, environment out in the field as well. Second component is the mobile application, and that's really for supervisors, so we're not expecting everybody out on site to be using a smartphone at all times. But that gives a supervisor a real overview of all those zones, perhaps the hazards out on site, and they can select any of those zones, get information on it, so it really gives them some really good location context as well. Make sure that the key thing that they're working in the right place and their people are in the right place as well at any point in time. So that's the mobile application. And the final one, really, the wearable devices that we use. So really for people out on site, but we also have tags that we can put on plant as well. And that's what really monitors that location and feeds back into the system. And what we've developed, that I'll come on to shortly, and the key thing for this is really the location accuracy. And we've got sort of survey grade technology in there that gives us sub 100 millimetre accuracy for locating people. And that's a really key point when we're looking at safety of people on the railway. So a quick overview, this is live view. So this is sort of your control centre, as I would say, on the portal itself. And it does what it says, really. It gives you a live view of where your people, plant and equipment are at any point in time. As you can see there, the user data anonymised, and I'll come on to that in a bit more detail just shortly. But again, from a context point of view, making sure people and your resources are in the right place at the right time. You know, this is a really good, simple view for your supervisors to, you know, to make sure that everything's happening as it should be on a possession or a work site. And a little bit about the history of, I guess, the hardware and the devices that we use. So historically, we've used the Zero and the Pro, which were 1 metre, 2 metre accuracy, and that's what we've used traditionally. When we got into discussions with Network Rail, it was really apparent that that location accuracy needs to be improved. If we've got people working on, you know, adjacent lines, then you know, 1 metre, 2 metres is a long, long way. So we needed to improve that accuracy. So what we've developed there is really using that survey technology to give us some enhanced accuracy on that location. So out in the trials last summer, as I say, over in Western and in Southern region, we were trialling the plus on the left-hand side, as you can see there, and that's got visual alerting, it's got audible alerting, and it's got haptic alerting as well. So it will give you a clear indication if you do step out of your safe area. So we were trialling that. We got some really good feedback from the teams on site. A lot of it was very, very positive. The things that people wanted to improve really was the ergonomics of it. So what we've done, we've taken that back and we've integrated the antenna now into the handset, and we're also providing a small OLED screen as well, so we could send simple messages out to people to give them some context about where they are at that point in time. So not just the alerting alongside that. So the main components exactly the same, but there's just some slight enhancements on the ergonomics from the feedback we've received out on site. And just to explain a bit of background about that technology that we use for locating people. So traditionally, if you use your smartphone, that will use GPS technology. And yeah, 1 to 3 meters if you're lucky, if you're outside and you've got a clear view of the sky. What we typically used with our early devices was GNSS, and with that we use every satellite constellation that is available to us at any point in time, and we select the best one. There's some intelligence in there that selects the best one of those. But to get the enhanced accuracy, we've moved on and we've used 2 other systems as well. So UWB is a really good system in certain circumstances, but it does require quite a bit of infrastructure to be put out that has got a range of 100 meters or so. So what we wanted to do was make sure there's as little setup as possible at the start of a possession or a work shift. And with that, what we typically use is what we call RTK. And that's typically what is used in engineering surveying equipment, so what your land surveyors will use out in the field. And with that, we have base station network out there, and each base station will cover a 20-kilometre radius. And with that, that will give correction data back to our devices, and that's what gives it the really high accuracy effectively. So again, one of the key things about our system that really makes it a game changer is there's very little deployment at the start of a possession. You could give someone a device, make it operational and have it checked within 20 seconds and they're out on work. So it's not taking any time out of their, the valuable possession time. A key thing I just touched on previously, really important for people, absolutely, is privacy. And we've put some measures in place to make sure that that is maintained at all times. And there's a few layers to this. The first of this is user data. So as you see, we don't present names on the system. It's completely anonymised. We can't relate that identification number to a person. Each time you go on a shift, you'll get a different number. So it's not about monitoring individuals. It's just about keeping people safe and giving them that tap on the shoulder, as I say, if they're potentially going into harm's way. The other thing we do as well is we only monitor within the network rail boundary fence line. So we set a perimeter zone and we drop off monitoring as people leave the access point, and as people come back within that perimeter zone, we will start monitoring again. So that's another measure that we've got to protect people's privacy. And thirdly as well, we can also set working times. So on top of that, an additional layer, if you only wanted to monitor between certain hours, then again, that's another layer that we can add in onto that privacy, which is a really important part of the system. And some other use cases in rail, obviously the main front and centre is that preventing loss of situational awareness. Other things that we can do with the system, people-plant interface risk. So we can put a device on an excavator or another item of plant. We can create a zone around that device, and that zone will move as that item of plant moves as well. So with that, we've got mobile exclusion zones too. So if someone enters that exclusion zone, it will alert them that they're too close proximity to that item of plant. Runaway alerting as well. So that's something we actually developed while we were working with the Western region. So what we can do, we can allocate someone to an item of plant, a track trolley, and if for some reason they move too far apart from that nominated user, and we can see that moving away at a certain speed, then we can trigger an alert to everybody out in the field to give them make them aware of this potential hazard as well. So another use case that we've developed. Creating zones for hazards identified on site. So this is a fairly new one as well. So if I'm moving out on site and I've located a new hazard that no one's aware of, actually from the device I can create my own zone. So I can drop a zone in a location to make people aware of that. That would become visible on the portal. Or another use case, if say I was going out to do some welding out in the field, I could put a zone around myself as well. So and take that off at the end of my work. So again, some added functionality there. And the final one, correct marker board and protection installation effectively. So we can attach these devices to marker boards, to strapping. We can create a zone where they are due to be installed, and we can send out a positive alert as well to show that they're in the correct location. So again, same technology, just a slightly different use case for that. And a little bit of sharing from other sectors as well. One thing that we've been working a little bit with on national highways is preventing buried service strikes too. So with the devices, we can actually attach them to an excavator arm close to the bucket. We can actually map the location of known services, create geofences around them, and then we can alert the operator or alert the banksman if they do come in too close proximity to those services as well. So again, same technology, just slightly different use case. Something we're seeing on a few major projects around the UK at the moment in enabling works and the like is really managing land access. So where am I allowed to go at the moment? Where have we got permission to go and access? And aligned to that as well, environmental protection. So, you know, ecological assets. Have I got a great crested newt exclusion zone? Have I got dormice? But again, it's making sure that, you know, we've got that environmental compliance in there and we're not doing any environmental damage too. So, you know, a similar use case to the safety. And it's always been very hard to evidence compliance. You know, have I been in these areas? And with now, you know, we can actually show that we've not triggered any alerts. We've got the evidence to show that we actually have been compliant as well. And that's a really powerful tool for people. And finally, and this is really an offshoot of, I guess, our main goal in relation to situational awareness, And you know, there's a quality benefit to that as well. So it's about getting the right people in the right location to do their work, really. So they know they're in the right place and that work's getting carried out as planned. So, you know, absolutely front and centre, the safety benefits as an offshoot of that. There's a real right first time quality benefit as well from that perspective. And a little bit about what is next for us on rail. So we've got a very long future roadmap of things we'd like to develop, and we get lots of feedback and ideas all the time. Some of the things we're looking at next, we've got the technology now to do tunnels and covered areas, so it's really been able to go out and demonstrate that in the field as well, about how that works. So that's one of the next steps for us. Zone creation at the moment, zones and alerts. It's a very simple process, but I think there's even more automation that we can add to that. You know, an integration with some other network rail systems as well to, you know, to make that as streamlined as possible. So again, that's a key thing for us. And finally, enabling collaboration between different organisations. So we may have 2 or 3 contractors coming together, working in very close proximity. How can they share their information on a temporary basis? If they're collaborating on a project or if they're working very closely, how can they share their location data of their users with each other for, you know, for a set period and collaborate on that basis as well? So we'll say we've got a long roadmap. Those are some of the things that are front and centre for us. And that's coming to the end, so thank you very much for your time today. The one thing I would say, if there's anything that's triggered a thought process and you've got any other ideas, we've got a long development roadmap, but we're always interested to see or hear other ideas that people may have around new features and new functions that we can add to OWL. So I hope that's been of interest, and I'm sure we'll be taking questions very shortly. Thank you.